Our Zenon Challenge project has three aspects: tank system, controller and SCADA screen. Tank system contains wooden frame holding all the equipment together and in right position, 3 plastic tanks and 2 rubber tubes to store and transport water, 2 valves made of Lego blocks and motors, steerer made of Lego blocks and motor, Lego infrared sensor used for distance measurement. We designed and prepared our control system using the ladder diagrams and function blocks in Straton, software provided by Copadata. It can work in 2 modes, manual control or automatic control. In manual, you simply use switches in Zenon SCADA to perform action you wish on the tank system. In automatic mode, state machine was created to perform actions in programmed order. In initial state, water is only in top tank, valves are closed and steerer is off. Then program opens the higher valve to fill the middle tank. Infrared sensor measures the distance to the surface of the water. In our program we did some scaling, and on the screen we can observe water level in centimeters. When required level is reached, the higher valve will close itself. Then, after a moment, steerer starts working for 5 seconds. In next state, water is flushed from the middle tank when the lower valve opens. As soon as infrared sensor detects the bottom of the tank, lower valve will close itself. Then whole process starts from the beginning. Let's take a closer look on the middle tank. Let's take a closer look on the bottom tank. In Zenon environment, we created a SCADA screen which we can use to monitor and control whole process. On the left side of the screen, we placed middle tank model with both valves and steerer. All active elements light green or red depending on their state. On the right side, we placed control panel. Top switch is used to change modes. Rest of options are unblocked when mode is set to manual. Then we can see switches for both valves and steerer. Between mentioned elements is a screen where communicates appear. It displays current state and alarm if water level is too high.
We are gonna start with our main steering structure. We have a main program steering a robot and other functions responsible for steering. Let's get to the program. In SFC we can see a finite state machine responsible for steering. We have an autonomous mode. Yeah, this is the autonomous mode. And high-mi mode, visible here downwards. Those two modes are responsible for the appropriate work of a robot. In high-AMI mode, we can make the robot move forward, backwards, go left, right, or open and close his gripper. There is always possibility to leave, to stop the robot. After the stop action, it goes back to the autonomous mode. In autonomous mode, we can tell him the distance and the angle. Those two values are being determined by the data from our driver. Also, there is the path, the main algorithm, that it is moving when it hits his own program. At first, it moves to be set to the can to get the direction. It goes to the can, it closes his gripper, it goes backwards to the first position, he goes to the base position and he puts the can back. After that, the loop is closed and the robot awaits another start command. To be sure everything works properly, we started with a manual mode where we can tell the robot where to go. Here's a little bit of presentation. I'm telling the robot to go left, he moves left. I'm telling him to go forward, and then forward, it goes right. Now I'm gonna close the gripper and next move right. Automatic mode consists of 5 functions. Start and calibrations need to be done at the beginning, where we need to transfer units from pixels to centimeters. Base position used to determine the first position of the can, and get angle and get distance are used to tell the robot how to get to the can and what is the distance he should cover. Okay, but how can we get those functions work? Well, we are using a dynamic link library written in C#. Those things are getting data from camera. This is the function responsible for starting the camera. At the moment when Zenon runtime is activated, this function is pending, and when Zenon runtime is being closed, the inactive function runs and it stops the camera. Well, this is the macro region where every function that we use is saved. It's obligatory to call the macro at the beginning, and so we have possibility to set base position, begin the calibration, end calibration, get the distance and get the angle, and there is possibility to start robot then run robot, which basically gets angle, gets distance, and when it has those two values, it calls the infinite state machine the program to move the robot. And this is it. Basically, this is the outlook on things we've written in C#. Now it is time for the most pleasant part of our presentation. We're showing successful trials. You can see that the robot is moving smoothly. With no bigger problems, you can transfer the can back to the base position. It's easy to see that the action is happening on the white poster. We're using it because it enables us to determine the circular shape of our camera. At the top we have a light source and a camera gathering data for our algorithms.
What you can see here is the robot that was built by us. Its task is to sort the bricks depending on the colors. Next you can see the control panel, where the actual status of the robot can be monitored. On the top of it, it's the name of the robot, then we have the run stop button, the power of the line that can be changed using the slider, there are some bar displays showing the speed of the motors, and bricks counter, which will be updated. Just updated. Okay, so the production line is ready. We set some line power and press the run button. The line starts to go, and we have the green brick, which is stopped by the ultrasonic sensor and the color sensor. The brick is catched and put to the right box. Here you can see the status of this part on the control panel. The red brick, and it's put it to the first box. It's properly, and here we go. The counter is updated. There are 2 bricks counted. There is the blue one, and the blue one should be put to the third one, and it is. Of course, there is another update, 1 brick of each color, and yeah, you can see the speed of the motors and so. So here we go. The arm is waiting. When brick stops, it goes down, catches the brick, and puts it to the first box, because it was the red one. Then we have the second, the green. Actually, it is the fifth one, but yeah, the second in the line. So yeah, and here we go with the blue one. It's the 6th brick, put it to the third box. And now you can see how everything changes on the control panel. Yeah, the current brick is updated, of course, properly to the color of the brick that is put it on the line. We can just move up the slider of the line power and speed up the process. Yeah, so actually the robot is working in this way. Here is some other short movie presenting how it goes, and yeah, it's sorting the bricks properly. There are 3 boxes, 3 different colors. The light sensor usually has no problems with it. If it gets dark, it may a little bit disturb the sensor, but there's actually no problem with the good light. Here is the big brick that's made with 2 small bricks, no problem. And the last one, the blue one, and it's put to the third box. Thank you for watching. Vote for us.